Yes.
Okay. Someone coming? I just wait for him. So then, hello and good morning. My name is Heike Prof, and I have a share in General Business Administration and International Automotive Management at the University of Duisburg-Essen in Germany, and I'm very glad to be here. And I welcome all of you here in Bordeaux, those who are connected online, and of course my great panel with very recognized discussants I will introduce in a minute. The topic today deals with a very hotly discussed issue, perhaps the most hotly discussed issue in the automotive industry at the moment, and its convergence and divergence of trajectories of change. Are we at the end of the case paradigm? And will the dominance of established OEMs soon be over? And this topic I will discuss with those people, and will give you a short introduction into this topic first. Regarding the transformation of the automotive industry, we have extremely contradictory scenarios. First, concerning the questions, are we at the end of the case paradigm in the automotive industry? Because on the one hand, we have the scenario, there is no case. No connected, autonomous, shared and electric mobility. I heard this first when we prepared this year's Gerpisa conference last year, this scenario. And it was argued, oh, the internal combustion engine. It is very much delayed at the moment. And autonomous driving, especially in mixed traffic, it's far away. And shared mobility is not profitable. So there is no case. But on the other hand, we have the second scenario. The case paradigm is accelerating. And it was argued, you can argue, it is driven by new competitors from the tech industry, from sharing providers, and from new competitors from North America, Tesla, or from China. So you have these two extremely contradictory scenarios. And secondly, the question, will the dominance of established OEMs soon be over? And it's connected with the first question, because if you follow the first scenario, there is no case. Then you would argue established OEMs and large suppliers will remain system integrators, and they will continue to dominate the automotive industry. But if you follow the second scenario, that case is, or the case revolution, how it's called, is accelerating, then you would argue that OEMs and large suppliers will be displaced by the new competitors from the tech industry, from car and ride sharers, and from the new competitors from China and from North America. I would assume that the truth lies in between. But the question is where? And this is what I would like to discuss with this high-caliber panel. And I'm very delighted to introduce the panelists. Therefore, I need these cards, because I would like to start with John Paul. John Paul MacDuffie. He was an assistant and associate professor at Wharton School University in Pennsylvania, and has been full professor since 2014 at the Wharton School in the US. He's one of the most well-known researchers in the automotive industry, starting from his PhD thesis on flexible production systems and manufacturing performance in the automotive world. He was the director of the program on vehicle and mobility innovation, and it was formerly the International Motor Vehicle Program, the IMVP, which has its leading study, The Machines That Changed the World. John Paul received a bachelor in sociology from Harvard University and his PhD in management from the MIT Sloan School of Management. He's well known for his publications in leading journals, and he's worldwide cited. He has received a lot of prizes, prize for his dissertation, best paper awards from journals and conferences, and excellent teaching awards. It's great to have you here, John Paul. Thank you for coming.
Thank you.
And then we come to Professor Charles John Humphrey, our second panelist. He's an honorary visiting professor at the Sussex University Business School in the UK. He has 40 years of experience in the area studies and international development studies, including research in Latin America, in Africa, and in Southeast Asia. Research management experience as a team leader of globalization in the team of IDS, and as a director of various international research programs and projects. Consultancy and training work for many bilateral and multilateral bodies, extensive teaching and administrative experience at the university, widely cited research in the fields of publication in leading journals, especially on governance of value chains. And John Humphrey received his bachelor in philosophy, politics and economics at Balliol College in Oxford, and a master and a DPhil in sociology at Sussex University. So dear John, I'm glad you are here. Thank you for coming. And then we have Professor Hua Wang. He is a full professor in strategy and innovation management, is an associate dean of Emlyon Business School, dean of Emlyon Business School in Asia, and French dean of Asia-Europe Business School, East China Normal University. His research interests center on innovation management, on globalization strategy and, of Chinese companies, and the automotive industry in China. He has more than 100 publications in journals and books and so on, and has taught courses, MBA, EMBA, at leading business schools. He's in the steering committee of Gerpisa and the vice president of the China Goes Global Association. He received his PhD from the Université Pierre Mendès France in France. Hua, thank you very much for joining this discussion. Thank you for coming. And last but not least, we have Elmar Pritsch. Dr. Elmar Pritsch, he is a partner at Deloitte and the global leader of software-defined vehicles at Deloitte. He focuses on strategy development and implementation based on his experiences with digital transformation, emerging ecosystems, alliance frameworks, and partnerships. Elmar studied computer science with a minor in business administration and a subsequent doctorate at the RWTH Aachen in Germany. He worked as a strategy consultant and a manager for international corporations in telecommunication, IT service, and also in the automotive sector. Above all with Bosch, most recently as the Executive Vice President, Corporate Sector Information Systems and Services, the CIO. And he was a co-founder and the COO of CBS Financial Industries, and he has more than 15 years of experience as a board and a supervisory board member. So a very recognized, fascinating panel, and I'm very happy to discuss our questions now with all of you. And let me start with the first question. So
Press the button.
No, perhaps close to you.
No, close the mic.
The mic?
It's on.
Yeah, that's fine.
It's fine? But here. So the first question is where in the continuum I showed on the slide before, in the introduction, do you see the future? So towards which of these extremes in the automotive industry, where will they develop? Is it a disruption happening in the case revolution in the automotive industry? Or will it be delayed? Or will it not take place at all? And where will the established OEMs and large suppliers will end up? I would like to start with John Paul, then Elmar, Hua, and John. John Paul?
Okay. Thank you, and thank you, Heike, for organizing the panel, and to Gerpisa for the invitation. I always enjoy coming to Gerpisa. I learn a tremendous amount from this kind of gathering of scholars from all over the world studying this very important sector, and that's been a continuous thread, I guess, in my happy experience of studying this industry, because IMVP and PVMI also brought international networks of researchers together. I'm going to step away from the question a bit by arguing for kind of unbundling case, and that perhaps also means that we see some other paths besides the two verticals that Heike showed in her slide, and perhaps focusing on the question, very important question, of how quickly can all of these actors learn the things they already don't know very well how to do, because there's a blending here of knowledge and capabilities and how to compete in this important transition. For a while now, I'd say in my ongoing work with Michael Jacobides and Jennifer Tai, we've been separating E, the electrification, from CAS, seeing different dynamics with respect to those, probably for many of the questions in the panel, so I'll try not to answer all of them in this initial question, so I would say electrification is being very heavily pushed by regulation, as we all know, beyond the growth that would occur naturally from consumer demand. And amid this growth, which I think any of us who follow this closely know, electric vehicle volume is still growing, even though the inflection, the slope rate of growth has slowed to some degree. Our view is there will be a big role for legacy OEMs as well as some new global OEMs. I'm starting to think, at least in my own mind, who would I put on the list of new global OEMs that I think will last, and I would certainly put Tesla and BYD and maybe Geely, or we have to decide about the Chinese beyond that, and maybe a few EV startups. So I don't see lots of EV startups surviving. I don't assume that all of the legacy incumbents will survive either, but a big role for them. So in contrast, the connected autonomous services is advancing at a pace that I think is much more anchored in technological developments, and the role of regulation is going to be to slow it up rather than to speed it up. So that's already one kind of contrast. And because software is so important, the potential for disruption by tech companies for CAS is much greater. Legacy OEMs obviously struggle with the shift towards software-defined vehicles, as I'm sure we will discuss. Probably to unbundle a little further, I think it's useful to think of each of the four technologies represented by the CASE acronym separately, and then think of how and when they're most likely to combine, and in what ways. I mean, I think, if you think of the robo-taxi services that we imagine may emerge, even in limited ways, they are autonomous in their services. They'll probably all be electric, I mean, given the way the world is going. But not all electric vehicles, obviously, are going to be using advanced autonomy, at least not anytime soon, and they won't necessarily all be involved in services. I also find it useful for the A of autonomous not to only think of level 4, but to think of the full range of driver assist technologies that are gradually adding both safety and the ability to transfer some control away from the human driver. And so even if level 4 autonomy is delayed, the sort of more quiet advance of the technologies through levels 2 and 3, and the still pending regulation of all of those levels, I think makes for a very interesting topic in the A category. We have, I think, another question coming on the S of shared or mobility as a service. I think there's tremendous variation across the world on this, but I'll just give you quickly a U.S. perspective. So far, based on some recent U.S. data from the metropolitan areas that use services like Uber and Lyft most, there's actually a small increase in average vehicle ownership in those metropolitan areas, rather than what many predicted, which is that vehicle ownership would decline as the increase of ride-hailing went up. So I think we can discouple the S a bit from what's happening with C, A, and E for privately owned vehicles. I think privately owned vehicles are not going away maybe as soon as we might have thought. And finally, just to touch on the role of the established OEMs, I've long been associated with the position that yes, they are system integrators. Those are valuable capabilities. They have relevance to the world of the future for mobility and relevance and value. From my point of view, electric vehicles aren't turning out to be as modular in their product architecture as many predicted. I mean, there are modules, as they're called in the industry, but if you want to talk about some of the classic definitions of modularity in the technology literature, there's not a kind of standardization and commodification and clean, simple interfaces as you would expect. Also we don't see a kind of disaggregation of supply chains in the horizontal way that we saw with computers. The most successful EV companies, Tesla and BYD, are the most vertically integrated companies in the world. So if we thought that electric vehicles were going to be associated with, I don't know, battery manufacturers becoming the powerhouse and outsourcing the manufacturing of EVs to contract manufacturers, completely bypassing the legacy OEMs, I think no prediction is further off, at least at the moment, than that one. And so I think, as we'll debate, the software question is huge. It's more central to CAS than it is to electrification. But I'll just sound one theme, which is, big tech is terrific at software, but they don't know anything about the physical world of cars and the regulatory requirements of cars, as in my words of my friend Taka, heavy, fast-moving objects that operate entirely in public space and kill people and do a lot of other damage as well. That's not exactly what smartphones are. OEMs are maybe, we could say, terrible at software, but they have the more mastery of that physical world. So I think each of them knows things the other doesn't know. That means they kind of need each other, even though they don't really want to depend on each other. And I'll close on that note. I'm done.
So thank you very much, John Paul. I just want to pass it to John. To Elmar. Sorry.
Yeah. So thank you for bringing me on this honored panel. I'm really happy to be here today, and I think it will be a fascinating discussion because I'm maybe a bit more radical in going to the right side of the picture, so going to scenario 2. And I agree, I mean, the one needs the other, so the new tech needs the classical traditional OEM, but the question is who needs the other more? And when we talk about Tesla and maybe also some new greenfield approaches with a super success coming from China, I believe they are not covering 100% of the market. They are just covering maybe up to 20% of the market. So we're talking about 80% of the market that is not yet covered and not yet clear what they need to do. And from my perception, we are talking to many OEMs, to many suppliers globally. If they continue as they do in an evolutionary way, they will die. Very simple, very clear, because those companies like Xiaomi, I mean the smartphone company, building a car is possible. But I'm not so sure whether an OEM would be able to build a smartphone, to be very honest. So I agree, both are needed, and for three reasons in particular, and these are maybe also the dimensions that you're seeing in the diagram that you're sharing, Heike. I think there's an absolutely different understanding of dynamics, pace, and speed. So traditional OEMs take 3 to 4 years to develop a product. I would never, as a software developer, start anything that lasts 3 or 4 years because I don't believe in it. So this is an absolutely contradictory paradigm. The second one is software is never ready and never bug-free. Meeting an industry that has a zero fault tolerance policy. So they are perfect in building perfect products that don't have any default, any fault or any mistake with the product delivered. And you can see it when you visit the factory, how much energy OEMs put into the building of perfect products. This is not the same with software. If you want to develop and deliver a perfect software product, you are too late in the market. And the third dimension, it's about the ecosystem play, and then talking to your integration. I agree, I mean, Tesla has a highly integrated approach, and I would compare this in the smartphone world to Apple. But again, we are at the 20% market share. So what do the other 80% do? And I'm observing the need for going together, building alliances, creating de facto standards in the world in order to scale. And this is something that I believe we will see in addition to those who have started with a very high vertical integration, and they will maybe, those associations and those standards, and I think here the industry, the research, and also the politicians should work together in order to make it happen. Because de facto standards don't just evolve like out of nothing. So I think joining forces here, working together, is a super attractive goal in order to save the automotive industry and to make it successful.
Thank you very much. So at least a little bit discussion, a little bit controversy, or one side and more the other. So I'm interested how, John, how do you see it?
Yes. We follow moderately. Yeah. Okay.
No. Hua. Yes, sorry. Hua is the next one.
Again, thank you, Professor Prof. It is my great honor to be here. And I would like to continue the discussion by two extremes, and in a Chinese way of stick in the middle. So I will provide with some figures to say that we are close to the middle. Below are the data coming from China. If you take a look on, if we make an abstract concept about the diffusion of innovation, it is measured by the market share from new product, right? So to give you the figure, you see that new energy vehicles market share for new sold cars was 5.6% in 2020, so during the pandemic. And this market share reached 31.6 last year in 2023. And this market share continued to make the progress according to the statistic with a cumulative of the first 5 months in China. New energy vehicles have sold 3.895 million. That represent 33.9% of the new cars sold. So from that perspective, we are, there is the estimation to say by the end of this year, the market share for new energy vehicle will close to 40%. So we are not far away from half ICE and half new energy vehicles in the coming 2 to 3 years. So this is a kind of the significant paradigm shift, at least in China. Despite, as Elmar said, that at the global level, it represents, a marginal part of 20% of the global market. Bear in mind that China now is producing 30 million new cars per year, producing and selling, right? So if in the future half of these 30 million cars will be electric or new energy vehicles, despite its marginal at the global level, that is shaping in a certain region called China. So by providing this type of figure, I think that we do see that the landscape in China is changing very fast. We have talked about from the industrial perspective, and I think that we also need to understand why Chinese consumers are ready to buy, because it's people are not forced to accept or to buy new energy vehicles. One observation is about, we are using smartphones compared to the old generation of Nokia, to make a kind of the metaphor. And Chinese consumers are more tech-savvy consumers, ready to embrace the case, paradigm. Secondly, we are calculating our cost of operations as well, right? So from the purchasing part, you can see the price is affordable now. Yesterday we discussed about Class A electric vehicles that do exist in China. Secondly, in terms of operation of the car, we can see that instead of fueling by gasoline, using electricity is significantly cheaper in China. For sure, different countries have different price and alternative between the gasoline price and the electricity price. But at least in China, that is the case. That will save you roughly, say, 500 euros per month as a kind of, expenses. So from that perspective, Chinese consumers are accepting this type of a new product in a significantly high speed of adoption from the market. And if we're coming back to the remark by John, we see that currently two leading car makers like Tesla and the BYD are taking a kind of vertical integration approach in terms of architecture design. While during the coffee break, Elmar has mentioned another emerging wave of technology. The platform strategy innovation is using the skateboard approach, right? So leading battery companies like LEVT, Cattel. Yeah, Cattel is initiating and betting on that technology. To simplify, to say that leave the bottom part to us and try to personalize your electric vehicles as you wish. So that is their new strategy of development, right? Without talking about some other startups, both for passenger cars and for commercial vehicles. So I prefer to stop here first, and we can move another round of the reflection and the discussion.
Yes, so thank you very much, Hua. And now we come to John.
Well, I won't say too much because I think I run the risk of agreeing too much and repeating what other people have said. But I think that yes, we have to decompose case into its different elements, and once you do that, then you have to say to what extent does the advance or backwardness of one element influence the implementation of the other elements, and see that look at those types of interrelations. I should also say I think it is very difficult to make projections. There's a lot of volatility. I've subscribed to Automotive News, and I find that the world seems to change almost every day. And I think that we just have to be aware that there will be speed bumps on the way about the speed of electrification of the rest. But if we just think about the four elements of case, then I agree with Jean-Paul that the electrification will is proceeding very rapidly, although I think the current anxiety about the lack of demand for EVs and the firms hedging their bets about continuing production of plug-in hybrids shows that it's not all plain sailing. And I think there are also some big technology changes going on. Again, in electric, we see how European manufacturers in the last 12 months or so have really started to think about LFP technology for batteries, particularly in the low end, because of the cost challenge. But in terms of the interaction then, I think that, electric is going on. I think connectedness, in terms of the narrow connectedness of information and entertainment, that also seems to be going ahead pretty rapidly. There's lots of investment, there are lots of companies providing different elements of that, the hardware and the software, and I think that that isn't a problem. The big problem is AV. It's been put back, it's being put back, it's being put back. There's a big issue around regulation, and I think if you look at the Mercedes L3 implementation in California, if you read their manual about how you can use it, it's rather salutary. Not in cities, that's only L2. Was it 40 or 60 kilometre speed limit? Now, they hope it will go up quickly, but how quickly? And of course, the extent to which that's going to change depends upon the regulatory specification of the operational design domain. And that's not under their control, and it not only requires regulation, but it requires infrastructure. You've got to have roads that can manage what the AV is capable of doing, and that's a big safety issue. So I think that's a big issue. And I think that, interestingly, I think in terms of mobility, you can say that the rapid advance in connectivity facilitates individualized models of car access. So, for example, ride-hailing and carpool sharing, but it's still a limited number of people travelling in a car that somebody owns or leases. Whereas AV, I think, undermines the real gains that you can make in terms of collective transport. If you read any of the sort of mobility transport systems literature, the really big advances come when you get AV in cities, where you can get intermodal mobility, you can get collective transport, which is much more flexible, much more integrated between the, if you think that mobility is really end-to-end, and a lot of collective transport is in the middle, then the interface between either end is really important, and a lot of that also depends on AV to be really effective and really cheap. And so I think that, in a sense, if there's a lag in AV and there's an acceleration of connectedness, we actually make the transport problem a lot worse in the medium term or the short term. So I think that's, I think we'll probably discuss that a lot more. As for the future of the incumbents or the large auto firms and the question of vertical integration, I think it's worth pointing out that vertical integration is a very common factor in newly developing industries, because you just don't have the supplier base. That was true with the railways. When they built the railways to take beef to Chicago, the company that built the railways had to provide everything, the water stations, because nobody in the Midwest was going to, was there to do any of that. And then gradually it decentralizes. So there is a possibility that we're in an initial startup period of increased concentration of vertical integration. I think also that maybe we have this big problem with cost and the ability to make a mass market low-cost cars. And I think that one route to achieving that is to have ready-made solutions. We saw that, for example, in the mobile phone industry in the feature phone period, when MTK, the Chinese chip supplier, basically supplied lots of very small Chinese firms with a system on a chip and a whole series of guides about how to implement it. So they did all the work, basically. Barriers to entry were very, very low. We might see something like that in the car industry, in the sense that you get a ready-made solution to your whatever level of automation or automated driving that you're trying to achieve at any point in time, and that will further lead to decentralization. I think, for example, that just to comment on whether, in a sense, the incumbents are ready for dealing with software. If you look at, Mercedes-Benz made this presentation last year in Sunnyvale, where they really went very strongly on latest hardware incorporated into the car, software updates, over-the-air updates, monetization. They seem to be going down that route. And I know that it's difficult for a car company. We had there's a presentation recently. I talked to somebody from one of the European car companies about how difficult it was to buy 4,000 software engineers from a company that was moving out of Europe and then integrate them into their company, and the logics of model changes and innovation in hardware and software are very different. But I think if you look at Mercedes have fully appreciated that problem and think they have a solution. So I think there is potential there. So, I'll stop there, because I think that many of the questions, or many of the things we've talked about, are actually going into more detail in the questions that we've already discussed, that we will discuss.
Yeah. So thank you so much. Just one question. So to what extent are the scenarios influenced by regulations in individual countries, and as well as by these overarching trade restrictions now between the United States and China, and maybe the discussion in the European Union? I would like to ask John first, then John Paul, Elmar, and Hua. John?
Yeah, I'm just talking too much. I just need a little bit of
maybe a little bit shorter, because we have some more questions to all of you.
Yeah.
Thank you.
Okay. Regulation is everywhere. And there was plenty of regulation, even in the ICE era, right? And that will continue. But the impact of the regulation obviously changes. So if we look at, I think that regulation has obviously, and it's already been mentioned, has a big impact on automated driving, largely because of safety. Already mentioned the issue of operational design domains and the limits on the implementation of AV, which means that it's outside of it's not the company that can, not a particular firm that can influence that, or even the industry as a whole. I mean, they can hope to influence it, but there are issues around infrastructure and the safety, which are out of their control. I think electrification, obviously not so much regulation, but certainly a lot of policy is really shaped, and that's a fundamental issue in terms of the development of the whole sector. But there are cases where the regulation has a very direct impact on not whether you have cars or not, but what type of cars. And Tommaso Pardi's work on the role of EU regulation related to CO2 emissions in driving the industry upmarket, even prior to EV, and getting larger, heavier, more powerful, less efficient, and more ecologically damaging cars as a result of the particular nature of the regulation in the European Union. And I think that on the question of shared mobility and regulation, again, this is a sector where there's a lot of regulation, but since there is a very specific question on shared mobility, I don't want to address that question at this particular moment.
John Paul? Thank you. John Paul, please.
Yes, another huge topic. Regulation has been, as John said, very important in this industry, will continue to be. Again, the work I've done in the past has argued that, in fact, the OEM's responsibility as the guarantor of quality and of certain parts of the regulatory process, legal liability, at least in the US, going to the OEM, not to suppliers, has sort of cemented a certain place in the value chain, and I don't think it's OEMs will complain about this, but in a way it helps them. But I want to start with a brief comment about a kind of clock speed, I guess, to use a term that my colleague Charlie Klein at MIT was one of the first, at least to me, to use. I mean, autos has a much slower clock speed than IT, even telecom. You might say one of the slowest, and for many reasons. And of course, it has speeded up, but everything has speeded up. So when you have a product that increasingly combines technologies of these very different clock speeds, I don't think we can assume that the faster wins, right? It's a complicated dynamic, and regulation is going to play a role in that around safety, around emissions. Again, to use a metaphor that Taka Fujimoto is frequently uses, designing a car to meet all of what customers want and all of what regulators want, all of what society wants, is like solving, thousands, maybe tens of thousands of simultaneous equations, and with everything changing all around it, you don't find the solution is the same the next time than it was the first time. So although the changes may not always be large, they require, again, the system integration, changing of many parts and how they go together. And with electric vehicles, one thing that I find myself thinking of when I compare to the fast-moving world of IT and software, we have Moore's Law at the heart of the rapid change. Moore's Law may be coming to, some kind of end, but anyway, the fundamental fact of Moore's Law, with exponential increases in computing power, with corresponding drops in price-performance ratios, up. Let's just take batteries for a minute. Battery prices have dropped impressively. Battery capacity has risen impressively. Battery chemistries are innovating. But there's no Moore's Law for batteries. I just think that's really important to remember. These are linear trends, and they look nicely steep, but they're not exponential trends. So the one thing that might be fueling this future mobility that still has some exponential quality is IT, what's happening on chips and what's happening with software. But most of the rest of the physical vehicle, not so. And so again, we have to ask what happens when you combine these different kinds of things, and how much the relative advantage of your knowledge and capabilities will matter. I'll just say a couple of things about regulation. I completely agree with what John said about AVs, and I've often thought the thing that would speed up AVs most would be two simple things. You have vehicle-to-vehicle communication that works really well, or you have vehicle-to-infrastructure communication that works really well. It's not just each vehicle autonomously sensing everything about its environment and making choices. Vehicle-to-vehicle requires, a kind of collective standardization and then installation into the entire installed base of all vehicles to really work safely, which I think is beyond anything we've ever seen in terms of, that kind of either standardization or retrofitting an installed base. And we know vehicles stay on the road for a very long time. Vehicle infrastructure requires massive investments, probably by governments. Governments are just catching up on a lot of other kinds of investments that are way overdue, and I don't see smart highways sort of rising to the top of the list or being available. But with regard to electrification, and again, this sort of alarm for some and pleasure for others in thinking that EVs are hitting a wall or slowing down. It's only the rate of growth that's slowing down. In the U.S., of course, we have a big election coming up, and everyone wonders what the consequences will be. One thing that I have tried to learn a bit about is this waiver from the Environmental Protection Agency requirements. There's new rules that have just been announced for cars and trucks. They're quite aggressive. They're actually going to accelerate a lot of changes, should they hold. Would those survive a change in administration? Well, the waiver that allows California to set its own separate emission standards has been hugely important. And there's 16 states plus District of Columbia and Quebec, I just learned, that follow them. That waiver has been challenged already a ton of times legally, and my legal colleagues at Wharton tell me it's pretty resistant to challenge. It can't just be overturned by having a new administrator at EPA. And I think that's quite important because the California Air Quality Board, or Air Resources Board, CARB, has really been the central regulatory actor in emissions reduction in the U.S., and it looks like their influence will continue to be strong.
Thank you. John Paul and Elmar?
Yeah, trying to give a short answer. Why do we have regulation? I think regulation is there to protect people with regard to IT security and with regard to safety issues with the vehicle. And why do we struggle at the moment in bringing new technology on the road? Because we currently use architectures that are by far too complex. And it's a competency topic as well. So who is able to get the complexity out of the system? The S-Class that you were describing, driving 60 kilometers per hour on a highway when the sun is shining and no construction area is around you, is from an engineering perspective a masterpiece. Thousands of engineers have worked in a task force in order to make this happen because you have a distributed architecture of more than 150 computers talking to each other in order to make this happen, while you have a high-resolution map streaming into the vehicle live. This is, from an engineering perspective, wonderful. From a software design perspective, it's a nightmare. Because you would never, from scratch, build a vehicle with more than 150 computers. Because the communication between those in order to implement just one single feature is ridiculous. So we have to get rid of complexity. That's the reason why greenfield approaches are so successful, and we have to help the authorities and the technical services to make regulation work. We can help them to define the use cases that need to be tested in order, and for me, I think connected and case really brings safety on the road. I think we have to turn it around and say, with this new technology, we will have less people dying in accidents because we are able to improve the product after the SOP, the delivery of the product. It will learn, it will improve, and it will be safer.